Hello everyone, this is Likita Chendula. Currently, I am pursuing my 8th semester in Sri Venkateswara College of Engineering, Bengaluru. The topic of today's explanation is Identification for Recycling Polyethylene Terephthalate Plastic Bottles by Polarization Vision. The contents of today's agenda is Introduction, History of Technology, Methodology, Flowchart, Literature Survey, Application, Results, Conclusion, and References. Coming to the introduction. In the modern world, plastic has become a universal material and plays an important role in many applications. That is, used for everything from throwaway bags to combat aircraft wings. Plastic is cheap, lightweight, and strong, and it can be synthesized with a wide range of properties. PET has become one of the most important packaging material for almost all kind of beverages, including juice, milk, and meat products, tea, mineral water, and some foods. The recycled PET can be reused to produce staple fiber, filament, packing belt, sheet, and food grade slice according to different quality grades. The methods for PET separation are divided into gravity, electrostatic, and magnetic density separation, flotation, and sensor-based sorting. Common plastic bottles are mainly made up of PET, polyvinyl chloride, polyethylene, polypropylene, and polystyrene. Three-stage sink float method and selective flotation were used for separation PET from PVC. PET bottles have a unique polarization signature which can be detected using polarization vision cameras. The quality of the recycling highly depends on the purity of the sorted raw materials. The reuse value heavily depends on the purity of the recycled PET. Coming to the history of technology, this technology can be traced back to the 1990s. The first patent for this technology was filed in 1993 by a group of researchers at the University of Arizona led by Dr. Victor H. Moll. In the year that followed, research continued to refine the technology and improve its accuracy. In 2000, Dr. Moll and his team formed a company called Polar Vision Technologies to use recycling facilities. Today, polarization vision technology is widely used in the recycling industry to sort PET plastic bottles from other types of plastic. It has proven to be an effective and efficient method for identifying PET plastic and has helped to increase the amount of plastic that can be recycled. Coming to the methodology, the first method is polarization images. In this stage, polarization image of the plastic bottles are using a polarization sensitive camera or other imaging devices. The camera captures the degree and angle of polarization of light reflected off the surface of the plastic. The images are then pre-processed to remove noise and artifacts and to enhance the features of interest. The second method is image processing and feature extraction. The images are processed to extract features that can be used to distinguish between PET plastic and other type of plastic. The third method which we have used is classification and identification. In this stage, a classification model is trained using machine learning algorithm such as support vector machine, random forest, or artificial neural network. The fourth method which we have used is recycling. In the final stage, the identified PET plastic bottles are separated from other types. Coming to the block diagram. This is the block diagram of this technology. Here is the conveyor belt, ejector, IPC and polarization CCD camera. The common recycling plastic bottle can be divided into four categories, that is PET, PE, PP and PS. In the terms of market share of all the beverages in the world, PET plastic bottles are called for more than 70%. In this paper, a new method recognition of the recycling PET pipeline by using the polarization vision is proposed the PT plastic bottle identification as shown in this figure. Here is the conveyor belt, and this conveyor belt we are going to place the plastic bottle by using a light source. When the light is fall on the plastic bottles, then the light is emitted. That empty light is captured by the polarization CCD camera, and it will be captured the image in four angles like 0 degree, 35 degree, 90 degree and 135 degree, and it also continuously captures the image of the plastic bottles so that it is easy to identify which type of plastic it is. Then, after capturing the image, it is moved to the ejector. The ejector will decide if it is PET or non-PET. If it is a PET, then it is fall into PET bin, and if it is a non-PET, then it is fall into non-PET bin. Then IPC. IPC is an intermediate processing center. It allows processor to share data with each other. This is the flowchart. Flowchart of PET bottle identification using polarization technology as shown in this figure. Firstly, the polarization intensity images were captured by using four angles: 0 degrees, 45 degrees, 90 degrees and 135 degrees. After that, polarization degree and the phase angle were obtained. After obtaining the polarization degree and the phase angle, the refractive index is calculated by using those two. And finally, SVM method is used to train the extracted features and set the judgmental criteria according to that. Coming to the literature survey. The first paper which we have referred is Performance Enhancements Based on the Data and Hybrid Learning for Recycling Transparent PET Bottles. The author is Subhajit Chatterjee, Dheerapriya Hazra in the year 2022. The pros of this paper is it is used to detect images of transparent plastic bottles. The cons of this paper is it uses two algorithms, which quite difficult to learn. The next paper which we have referred is Review of Waste Plastic Bottle Recycling Equipment Research Status. The author is Chenguchi in the year 2020. The pros of this paper is it produces cleanliness and neatness plastic bottles. The cons of this paper is without barcode, it is difficult to identify the plastic. The next paper which we have referred is two-way powered microcontroller based plastic bottles, drop and tap, reverse vending machine with stored value system using radio frequency identification, scanner technology. The author is Wisdom Gen P in the year 2019. The pros of this paper is it uses reverse vending machine. The cons of this paper is it uses RFDI for recognize the plastic, which may not be available in every case. The next paper which we have referred is Design for Recycling, Guidelines for Plastic Components. The author is E. Masanet and Sudha in the year 2018. The pros of this paper is it focused DFR efforts on those strategies which are most effective for improving product recyclability. The cons of this paper is DFR guidelines for computer plastics are not always effective for improving the recyclability of plastic components. Coming to the application, PET films are most widely used in heat stabilizer form for the manufacturing of shopping bags and videotapes, for manufacturing of water bottle and housing materials. PET bottles used for shipping. It is used in seat belts, roofing insulation, and even clothing. PET plastics in the food industry includes calm shells, deli containers, microwavable food trays, etc. These are the results. The method of identifying materials of plastic bottle described was verified by experimentally. In order to verify the practical application ability of this method, the field of view of the camera is 500 mm into 418 mm. The figure 4 shows different forms of plastic bottles in sample collection. Figure 5 shows the mean and standard deviation of the approximate refractive index. Here, figure 6 shows approximate refractive index distribution of PET. Figure 7 shows approximate refractive index distribution of PE. Figure 8 shows approximate refractive index of PP. Approximate refractive index describes of PS. Coming to the conclusion, this study proposed a new method to identification the PET plastic bottles from three kinds of plastic bottles with the different materials of PE, PP and PS for the purpose of the recycling. The image segmentation method is used to calculate a convex hull in the area where the plastic bottle is located. The polarization degree and the polarization angle in the convex hull of the plastic bottle are used to calculate the approximate refractive index array. The SVM method is used to learn the identification model for PET plastic bottle. The results demonstrated that the recognition accuracy of PET could reach 92.06%, missing rate of non-PET is 4.14%, and mistake sentencing rate of PET is 2.76%. Other methods have achieved a higher recognition rate in PET recognition. They are severely affected by environmental light and the cost of sensor is high. The new method of PET plastic bottle identification based on the polarization vision proposed in this paper is hardly affected by the light environment. These are the references. Thank you.